Talk about similar triangles today and the three methods of proving that triangles are similar to each other. There are three methods. The first method is called angle-angle, and if you prove that two corresponding angles are equal, then you are able to say that the triangles are similar to each other. Side, side, side. It works if you have three corresponding sides in the same ratio with the three of the other triangle. So you would set all of your corresponding sides in a proportion, and if they all reduce to the same value, then they are similar. And side angle side, where you have two sides that are in proportion with each other, as well as the angle that is in between those sides being congruent from one triangle to another. Things that you have when you have similar triangles, they are the same shape but not necessarily the same size. They have corresponding angles that are equal to each other and corresponding sides that are in the same ratio. Using angle-angle similarity, you just need to identify two corresponding angles from one triangle to be congruent to two in the other. The reason you need just two instead of all three is because if you know two angles in one triangle are congruent to two angles of another, then you could use either the third angles theorem to know that the third angles match, or you can use triangle angle sum to show that the remaining amount would be equal. Here's a sample question from Edgenuity. Determine which diagram could be used to prove triangle ABC is similar to triangle EDC using similarity transformations. So as we look at these, remember that similarity transformations, they're saying similarity because a dilation is a similarity transformation, but you can also use a dilation in combination with a reflection, a rotation, translation, all of those things. As we look at these pictures, we are looking to see if we can tell that the triangles are similar to each other. If we look at this first one, we can notice that we have already an angle pair that has been marked. We could also prove that the angles at the intersection here will be congruent because vertical angles are congruent. This pair of triangles, we are able to know they are similar because of the angle-angle similarity theorem, and so this is a correct answer to this question. Let's look at the others to determine why they would not be a good choice. This one here has one set of angles congruent, but that's all. We don't have any vertical angles, and there's no way to determine another pair of matching angles. The third option here does have multiple angles marked in each triangle, but in this first triangle, we have these two that match, and then in the other triangle, these two. And they're not matching to each other. This is basically two isosceles triangles, but we don't have a way to know that these angles are corresponding to each other from triangle ABC to triangle EDC. So since we're not able to kind of connect those triangles to one another, just separate isosceles triangles, well, they're not going to be similar to each other. Now there is a caveat to that. If the triangles were in fact equilateral, then we would be able to know that all the angles are 60 degrees and they would be similar to each other. So isosceles triangles, no, but equilateral, yes. So this first option is the one that you want. Side, side, side similarity can be found by setting up your corresponding sides in a proportion or a statement of proportionality, and then you can reduce those to determine if they are in fact going to be similar to each other. Here is an example problem from Edgenuity within the side, side, side lesson. It says given that DF over PR equals FE over RQ equals 3 over 2. What additional information is needed to prove the triangles are similar using side, side, side? Well, currently we have two sets of sides. I'm going to go ahead and highlight these. So we got DF and PR. Now remember, these are not congruent. They are in ratio with each other in the ratio of 3 to 2. We have FE and RQ. So the side that we do not have currently is DE and QP. And that's a side that we need. In order to use side, 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 you need ratios of all three sides. So since we know from this statement that they have given us, we know that we want them to be equal to 3/2 in order to be proportional so that all three sets of sides can reduce to that same scale factor. So we are looking for a ratio statement with 3/2 as part of it. That allows us to narrow down our answer choices to the last two options. Since each question, or proportion, the top segment came from the triangle on the left side, we need the top segment to come from the triangle on the left side as well. So we've got, and they both have DE. So that's just one thing to kind of think about in our thought process. Next, we should have DE being listed over side PQ because those are the ones that we had wanted to have in ratio that we were missing. And if you notice that the first option has it over EF, so that is why that one is incorrect, leaving us with that bottom choice there to be the correct answer. Here is another style of question that Edgenuity asks using the side-side-side similarity theorem. Can the pairs of triangles be proven similar using the side-side-side similarity theorem? So in order to do this, and this is two separate questions, so I'm going to zoom in here. What you do when you're testing side-side-side is you know that you have three sets of sides that should be corresponding. You choose one triangle for the top and one triangle for the bottom. I'm going to use the triangle on the left for the top. List the sides in order, shortest to longest. The reason I'm setting these in order shortest to longest is so that I can have an easy way of finding my corresponding pairs. The short should compare with the short, medium with medium, and long with long. Because if you're comparing the short side in one triangle with the long side in the other triangle, they are not going to be similar. So I did this triangle on the left as the top. I'm going to do the triangle on the right as the bottom. So again, list these in order of shortest to longest. So 6 is the shortest, and then 9, and then 12. Next, reduce your fractions to see if they are going to give you the same scale factor. Well, 4/6 reduces to 2/3, 6/9 reduces to 2/3, and 8/12 reduces to 2/3. Since these all reduce to the same fraction, they are similar, so we would say yes, similar, by, side, 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 similarity. And if they wanted the scale factor, we would say it is 2/3. Now, with the scale factor, sometimes they will say the scale factor of PTS compared to, X, Z, Y. And if they do that, if they have a phrasing where the listing the names in a certain order, then you need the scale factor to go in that order. People could say it's 2/3 or 3/2. It just depends on the phrasing of the question. Now, if it is a dilation, of course you want the new over the old. This was not a dilation question, therefore I chose which one was going to be on the top. Now, sometimes they want you to write a similarity statement, and the order that you write those in matters, just like it mattered when you had congruent triangles. So if I was wanting to name these, if I said RTS, R is between the short and the long. So you would go to the other triangle and find the short and the long. That would be angle X. So you would say similar, triangle, and then you would say X. I went from R to T, which is the short side. So I'm going to go X to Z, which is the short side, and then to Y. And so these triangles are similar by side, 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 similarity. Now, as I look at the second answer or second question here, what I have is I have some congruent markings. All of these are equal to each other based off the congruent markings. And this one is congruent to this one. So I'm going to label all my matching pieces. So because we had this marking here and here, those are both 5. We had the same marking here and here, so those are both 5. And then we had a double marking on the bottom and a double marking over here, so those are both 9. So in this case, with an isosceles triangle, 2 of the side lengths are the same. So we'll have 5 and 9. And then on the bottom, we actually have 5 and 9. Now, these triangles, the scale factor is 1, right? It reduces to 1. So what this means is that they are all in, ratio of 1 to 1. And they would actually be able to say that these are congruent by side congruence. Now, the definition of similarity, they could be the same size and still be similar. Not only are these similar, but they are congruent. So just kind of a caveat on there, kind of like saying an isosceles triangle could be equilateral, and an equilateral triangle is always isosceles. It's kind of like that. So these are similar, yes, by side similarity, and in fact they are also congruent to each other. Here is another one, question from Edgenuity. Kai found the following ratios. Is triangle PQR similar to triangle EFG? So they have the ratios for us here. The 9/18 could reduce to 1/2. The 15/30 reduces to 1/2. And the 19/38. Let's think, what's half of 38? Well, that would be 19. So it would also reduce to 1/2. Since these all reduce to the same amount, they are similar by side similarity. And we would circle that second answer choice. The third option for triangle similarity is side angle side. Can the pairs of triangles be proven similar using the side angle side similarity theorem? So we're going to look at a couple of questions here. They have told us this information, think of this as like a given, as well as being given these 2 angles. Since we know about this information, and there's like similarity doesn't have a way like for you to mark the sides like congruence does. Congruence, we'd put the little tick mark to match them up. And historically in my classes, my students have come up with a way to mark the sides in ratio. They used a squiggle rather than a congruency marking. So I'm going to go ahead and use their marking system. So PR, we're going to do a squiggle, and XZ, do a squiggle. And then the other set, we're going to do a double squiggle. And I'm doing this because they're not congruent to each other, so I don't want to think of them as congruent, but I want to think of them as corresponding. Now, you could also use different highlighter colors and things like that to mark your page. But you can see that the sides that have been marked are surrounding that angle that we know to be congruent. And this is how side angle side shows up in your pictures. If you have 2 sides corresponding to 2 sides in another triangle and the included angle, meaning that angle that is between those sides, then they are similar by side angle side. So this is happening for these. And if we wanted to name it, if I said PRQ, similar. So if I start at P, I need to start at the corresponding angle for the other triangle, which would be X, and then go to Z and to Y to have my matching pieces all line up. If I look over here at the second question on this page, I'm going to use highlighting for this one. So JL, here's JL, MO, and then we have JK and MN. Notice how those 2 side corresponding pairs would surround the angle at J and the angle at M. So for this to work out, I would have to know that angle J and angle M are congruent to each other. And currently, I don't have that. I currently basically have angle side side, which doesn't work for similarity. So these are not similar. And so those are some samples of side angle side. All right, I'm going to pause there with this video. I'm going to do a separate video to help out with Friday's lesson because I don't want this video to be forever long. So let me find the stop button.